Hello everyone. My name is Hearn Lee, so I'm currently working as a postdoc at the CSHub. So today we'll be talking about the Pavement LC and LCC2. We have been worked so hard in the past 1 or 2 years. Today our talk will be including about the from the design to the decisions when we're using the MIT online Pavement LC and LCC2 for the low carbon, cost-effective choices. So for our pavement, so when we're talking about pavement LC and LCCA, all the components will be involved, which includes pavement performance modeling, pavement LCA and LCCA, as well as the long-term performance evaluation when we're considering the trade-offs from an LC and LCC result back to our initial design decisions and the life cycle M1R, which is maintenance and rehabilitation strategies. From the integrated analysis, we'll be progressing to the long-term uncertainty analysis, which involve a lot of uncertainty in the long-term performance evaluation and decision makings, which need much faster tool or computational effective way for us to implement everything within a given tool. That's the reason we bring up the Pavement LC and LCCA tool as one to everything all in one platform. And also, because we are just talking about uncertainty analysis, which will not only impact our long-term performance, but also the results of those LCCA and LCA involving what's involved, which is the contextual data, climatic data, traffic loading data, material properties, and a lot of different material selections and structural design. So the last but not least, when we're having different designs or additive designs, which are considered equivalents in the structure or performance, but in the long-term LC and LCC lifecycle environmental impact and economic impact, we also need to understanding when these two pavement or two designs are structurally equivalent, what about their performance in terms of the environmental and economic impact? This way, we do the comparative and probabilistic analysis to compare these two design options. In this way, so let me introduce the Streamlined LC and LCC platform for we have developed at the hub involve the full pavement lifecycle analysis. We include the pavement LC and LCC from the design input data, which we just talked about, a lot of contextual data from geometric data, climate to the traffic. For design, we're not only designing our pavement structures, the layers, but also we're designing the paving material mixture design, including the concrete mixture design, as well as the hot mix asphalt design with their subgrade and base design in the structure performance. And also those mixture design and structural implement will be involved to evaluate the initial material and construction emissions, including raw material supply, transportation, energy, and fuel consumptions. But also the long-term performance is another significant component will impact our long-term performance in terms of distresses and also the use phase emissions and impacts, which will be also needed the life cycle maintenance and rehabilitation, which are M&R, will be used to be back to evaluate the pavement long-term performance through the timing, on-time, maintenance, rehabilitations to maintain the pavement in a good performance. But all these types of activities will introduce the embodied emissions, but also will impact our use phase emissions. For example, those pavement vehicle interactions, including the deflection and roughness. Now, another module will be the reflective radiative forcing, which also called albedo, which is related to reflective properties of the surface of the pavement. But also another point will be the concrete carbonation or CO2 sequestration. So all those components are involved in the life cycle analysis. The bottom and the top will be involved in the life cycle cost analysis. All the components will be involved in the life cycle environment impact analysis, including the embodied emissions or agency cost, and also the use phase emissions or the use phase users cost. So by implementing this given Streamlined tool or platform, we're able to evaluate or quantify the life cycle environmental and economic impact. So here is an example of the components of the LC analysis, we can see it involved in embodied emissions and use phase emissions, including the carbonations, which the CO2 will be observed if we are using surfacing using concrete material during the use phase. And also the albedo impact or radiative forcing. When the surface has a higher albedo, it will reflect more solar radiations to the atmosphere, or it can be translated to the CO2 reflective to the atmosphere, give off a cooler surface. If there's a lower albedo, the surface of the pavement will actually observe more heat or solar radiations from an atmosphere will be translated to more CO2 emissions in our pavement. Those are the use phase, but also we're also evaluating the initial emissions, including A1 to A5 from the raw material productions to the construction during the initial pavement construction. And also the M&R schedule or M&R activities are also being involved in this analysis, which are contributing to the embodied emissions. Another two pavement vehicle interactions or PVI interactions are shown in this red, the red right, which is the PVI deflections. When the pavement surface has a slightly lower stiffness, it will need our users of the vehicles to put more gas in to keep the same speed, which we call excessive fuel consumptions, which are contributing the PVI deflection impact. And also with a similar story, when a pavement is relatively rough, which we indicate using the international roughness indicators, when the pavement is rougher, we also need accelerating more fuels to keep the same speed. Those excessive fuel consumptions compared to a better or perfect smoothness of the pavement will also be contributing to the PVI roughness as the one significant components of the use phase for the pavement LCA. And the last but not least, the end-of-life emissions, including the C1 to C4 from the deconstruction to the disposal of the pavement. So now I'm happy to introduce, we have developed this pavement LCA and LCC2, including the framework we have just developed. The major step in this pavement LCA and LCC2 are split by 6 major steps. First, we also need to describe the contextual of the project. For a given project, the user will be asked, define where is the project, what is the state, and what is the climate of this project, what is the traffic of this given project if you're having the data. Another components, again, we're not only designing the pavement structure, we also design the pavement mixtures of this given material, including asphalt and concrete material. Third one, yes, when we're already defined our mixture design, we will design and evaluating our pavement structures. So we don't need other tools. The given LC and LCC2 we have here is able to predict long-term performance for your given structural design. And for the long-term performance, when there are any threshold of your distresses, or you want to have some default or business as usual material, so business as usual maintenance and reputation schedule, so it will be easy for you to implement for the pavement life cycle. The fifth and sixth will be the comparative and probabilistic analysis. We're using statistic analysis and visualizations to compare your pavement LC and LCC result if you have more than one pavement design alternatives, which is also interactive for user-friendly pages for you to play with those results. Okay, so now let's look at the pavement LC and LCC2 we have developed at the hub. So you can see both, we have the middle is the website. You can just tap the website. And also you can use the QR code on the right-hand side. You can just use your phone to scan. But you can see this screenshot. You may need to register before you can log into this tool to play with the tool as well. And on left side, you can see that we also have a phone version of the mobility of this website, but it's still under constructions. Now it's still a website, but tailored for the mobile phone users. It's not a app yet, but the app is under development. It will be released in the future. But I just want to let you know, if you use your phone to scan the QR code, you can still play with that and use your finger to tap that to scroll up and down for the tool to play with them. Okay, so let's go to the details of this tool. So step zero is still about the registration and login. So on the left-hand side, you'll be need to input your users, emails, and password for your account. And then when you already have an account, you can just directly log in for this tool. All right, so because I already have a tool and I already have account, I play with a few case studies of the tool. Here is my user's dashboard. So you can see that I have a multiple case studies I already performed for different scenarios. And you can see if I click any of these two, it will just pop out which case study have been performed. And if you click the actions, there are a bunch of options: edit, clone, or delete this given case studies on your own dashboard account. And also, this is just identical in the mobile phones of the right-hand side. Before started, actually, if you are not familiar with the payment LC, if you want to learn more how those each embodied or modules were modeled in the tool, or if you want understanding which of their input are needed and what is definitions, you can see there's introduction or get started page. And this page is on the document. If you are already logged into your tool, you can click this docs. Those givens, those different items give you better understanding of the tool. And also you can use that use your phone as well. But because I'm already familiar with tool, I will just do a case studies from the step 1 to 6, which we just introduced as the major steps to perform the payment LCA and LCCA. So you can see here, I have different unit conversions. You can use SI unit or the US unit. And for the case studies, I'm just using a sample from Iowa state, and I have a different cost analysis for the asphalt cost in the unit values, as well as the concrete cost, as well as the diesel and gas price, which will be so much important for the construction and energy producing when we're developing this raw material or during the pavement construction stage. And also, we can see this exactly identical thing. So in the mobile, and if you're having the data, or if you are interested in what will be the impact of your traffic, definitely we give you these options. We click the button of the detailed traffic data. So you will be see this additional page, which is called detailed context. Here it has everything from ADT per lane, ADT all lane, and the traffic truck percentage, ADT per lane, ADT all lane, traffic growth, speed, and reliability, which will be so significant to your pavement design. And because we include in the uncertainty analysis, because during the life cycle, there is a great uncertainty, especially for the traffic development. In this case, we have a different distribution assumptions. So on default, there's a uniform distribution, but you can see we are able to select from uniform, normal, log normal, and triangular distributions for different parameters of your traffic. If you're able to save random, so you will give your own specific traffic for your given project, which will make your evaluation more specific, or price precision will improve your precision of your analysis. So on the third step, you will see the material emission factors, which will be used to calculate the embodied emissions. You can see here, this is the concrete mixture design. So as we just talked, you were able to design your concrete mixtures. For this case study, we're actually using our default concrete mixture designs from NRMCA database, and we're designing the Iowa 4,000 PSI compressive strength of our concrete material. But we're able to make any modifications for those A1, A2, A3, which will be so significant to our pavement material emission factors or the embodied emission calculations. And as a result, A1, A2, A3 will be summed up as total emission factors. You can see we also have the conversion of the units, which help you to understanding the conversion of each unit if you're familiar with. And also, if you have any preference for the mobile, so please feel free with them, use with them. And also, we have given the options for the asphalt mixture design. So we have also including A1, 2, 3. And this is default design again for L hot mixture asphalt. But also you can change any of these values, RAP, even RAP and WAP content for your given asphalt if you have a specific mixture design for asphalt. But for here, we're just using the default values, which is publicly available, and they were already embedded in the tool. So as a result, you can see these total emissions are total emission factors as unit values for asphalt material, including also A1, A2, A3. All right, so given we have already defined our material mixture design, the next step will be definitely the pavement design, which is specifically the structural design. Here we have the GPCP, which is a concrete pavement. We have also unit conversion, feel free to play with them. And basically, it's a typical three-layer of the concrete pavement, surface layer, concrete base, granular base, and the subgrade. So we have give the customized design because if you can see on the bottom, we actually including two design spectrum, including the MEPD design and ASHTO 93 design, which are all available. But if you already have your design, feel free to click the customize design button, and those gray area will be turned to white, and you can just input any of your design. Given our min and max is the uh, aiming to the probabilistic and uncertainty analysis. If you have just one single design, just put the min and max at the same values. It will just go through pretty good. And also you can see a lot of design parameters will be so impactful for the long-term payment performance and will be further transferred to the use phase emissions and the cost for the LC and LCC analysis when we're using the PVI modules, etc. And on the right-hand side, as we just talked, those maintenance rehabilitation schedule or M&R schedule will also be planned for this given 50-year analysis for the bottom, as we can see. For this particular pavement, we're expecting about 35-year minus plus 2 years of diamond grinding. But you can see there's a lot of design M&R design schedules you can play with on the right-hand side. And again, yeah, this is design specifications, so we are just using that. But feel free to play with them if you're having your own design. And also, you can use the tool as the payment design tool as well. So feel free to play with that. And also, you can play with that, use your phone as well, no problem. But when you're ready for your design on the concrete pavement, we also have a asphalt pavement always as a benchmarking or alternatives for our pavement design. Very similar story, just the different specific material properties for the asphalt pavement. And for the right-hand side, you have the unit conversions and layers, customized design. Everything is the same functionality of the concrete pavement. But yes, this treatment for MNR will be definitely different. For this particular asphalt pavement, it is the structurally equivalent from my prior concrete pavement design. But you can see this long-term 50-year analysis period, I have a default about 20 years, which is minus plus 2 years AC mu and fuel as planned, as well as the 38 years minus plus 2 years of AC mu and fuel as well. So that is the default MNR schedule for this given asphalt pavement in Iowa. And you can use that as a structural equivalency alternatives. And also, if you are able to compare this to, or if you're willing to compare this to pavement, this tool give you a perfect place to play with them. And when your everything is ready, so when we'll click run pavement LCA and LCC analysis. So here is the sample results for this given case studies we have just performed. It is the Iowa case study. We have a 20-year design life if you're using our design components, but it is a 50-year analysis period. You can see these iterations, which is the number of Monte Carlo simulations, give us a strong idea of the uncertainty analysis are after the 50 years what will be the probabilistic of our LC and LCCA. So you can see we have a two structural equivalent design. We have about 6.5 to 8 inch of a concrete pavement and about 8.25 inch of asphalt comparisons. this asphalt is just very unique. It's just the one values, but it doesn't matter for this given. If you already have your asphalt design, for example, in this scenario, you just want to see what it will be the equivalent concrete design and what will be the life cycle cost and life cycle environmental impact for this design, which are equivalent in the performance. So on the bottom, so you can see our LCA results. So LCA results give you a flexibility for the computations or the user interactions. So for this blue one is the GPCP, which is the concrete medium, and light blue is the 95 confidence interval that was derived from the 100 Monte Carlo simulations. For the red one, it's the HMA or asphalt pavement medium. It also containing the light red, which is the distribution of your 100 Monte Carlo simulation when you're considering the 95% confidence intervals. But when we're talking about medium, we'll see that when initially the pavement, the asphalt is slightly lower than the concrete, which is around 1 kiloton of CO2 compared to the concrete is 1.2 probably. But after 19 years, these two medium pavement life cycle GHG emissions become equivalent. It's about 1.37 kiloton, which means that before 19 years, the asphalt pavements is preferable for the environment perspective. But after 19 years, you can see my blue line, especially the medium, it starts to be below and underneath the red line, which means from the 20 years or after 20 years, the concrete pavement becomes more preferable for the performance of the environmental perspective. And when we're talking about this 50-year analysis, at the end of the 50 year, the red hand side, the bar plot, give you the idea of what is the contributions of the life cycle greenhouse gas emission of each components. You can see we have initial aminor deflection, pavement roughness, reinforcing, carbonation, and end of life. So you can see what is the majority contributions of this pavement LCA life cycle GHG emissions. And you can see for different pavement, concrete and asphalt, the contributions are significantly different. And if your agency or if you're only care about, let's say, embodied emissions, feel free to play with this tool. You can see I just click initial aminor, end of life. All the other use phase component was deselected. And still you can compare these two pavements intuitively. And also we have the LCCA results. The top are exactly the same because we're comparing these two pavements. And on the bottom is the LCCA results. So you can see now you can better interpret our pavement. Now you can see this payback time from switching asphalt to concrete was about 11 years for this particular case studies, which at the time of 11 years or 10 years, it's just about $1.06 million for both pavement. But progressively after 11 years, the concrete seems like a more cost effective or lower cost compared to the asphalt pavement. And on the right-hand side, you can see the total numbers at the end of 50 years. Again, you can play with this agency cost if you select an initial aminor and end of life only. But feel free to click any of this or deselect any of this or select any of this component to see which you are interested in. All right, so as we just talked, we're interested about the statistical analysis or comparative and probabilistic analysis to compare these two equivalent pavement alternatives. So on the top, it's very easy to see that the embodied emissions are the use phase emissions. But for the bottom, we actually give you more idea of this statistical analysis for this given 100 Monte Carlo simulations. We're seeing that the blue part, which are all the columns are here, it means that the concrete pavement is preferable on the 100% perspective, which means for all these 100 possible futures, concrete pavement perform better than the asphalt pavement in the given case study for the environmental impact. And on the right-hand side is the detailed distribution of the life cycle greenhouse gas emission for these two alternatives. And also we have the cost analysis when we're also involved in the uncertainty analysis. On the bottom, you can see we have this similar plot, but now we can see that not all the bars are on the left. There are some bars in the middle, which statistically, they're actually about 92% of the probability or 92% of the future scenarios concrete perform better in a cost perspective compared to the asphalt. But statistically, when it's more than 90%, we will consider it's significant enough to make distinguish these two pavement alternatives for the cost perspective. All right, so again, similar story. You can play with that using your phone as well. All right, so another component you can see that when we're having this major LCA results, there are different items on my right-hand side. They're actually clickable. So if you are still not familiar with some of this albedo, for example, just click that. We have a one-page explainer for you to better understanding what is the albedo impact, how we are modeling this albedo impact, how significant is this albedo impact. And also, if you're mature pavement designers, if you're a pavement engineer for many years, you'll be also curious how we're modeling the pavement long-term performance. For example, how we're modeling the RI performance for the concrete or asphalt pavement. Just click this clickable link. You'll be linked to the academic report or publications for you to understanding how we're modeling them, while we're modeling them in a faster way that can be efficient used or match faster prediction for this multiple Monte Carlo simulations for the future possibility predictions. And again, so why it matters to our DOTs or agencies? Because we have now integrated everything in a single tool, including design, material, performance, MNR, LC, and LCC. And it's fast performance predictions, LC and LCC results. We have just seen that, which traditionally, if you're just designing pavement, if you're using Pavement ME, it took hours to get a single design. But for these two 100 Monte Carlo simulations involving both the LC and LCC and also the pavement performance modeling, it just took minutes. And also for the DOT's practice, so we have provide customizable for DOTs, the local calibration factors for the performance modeling. And also you can see we have involved all the states in the US to involve all the climatic and the traffic data. We have embedded all the default data for the practice for DOTs, but also we enable the users to modify any of those data to adopt for their specific project or case studies. And we can see that we are not only considering the LC, but also LCCA. And you can see the LCC and LCC are so comparable. You can see the difference if you're familiar or if you're only interested in the embodied emissions, agency cost, or you're also interested to see in the trade packet back time, how long you have to wait for one pavement alternative perform better than the other. What about the cost perspective? Sustainable pavement. There are a lot of things that come with them, make better decisions. And also you can see we involve the statistical analysis to give you a sense of the confidential levels of your results. Scalable across network, that is what we're working on. So it's not immediately available in the tool itself, but the tool or the framework gives us much faster analysis for the future possible analysis for different states or for the whole United States road networks. All right, so then we're bringing to some real case studies we have performed for our DOTs or states. The first of all I will introduce is the Iowa case studies, which is underneath FGWA Climate Challenge Program. We have a partner with Iowa DOTs with this I-35 southbound concrete pavement. Actually, this pavement, we're having two pavement alternatives provided by the Iowa DOTs. It's a 3-line pavement with 2 trailers on each one. But also you can see we have 2 pavement which are equivalent exactly performance in the DOT perspective. But they want to understand what about the environmental impact? What about the cost? So here, that's why we use our tool. So you can see that when we're giving the exact numbers, it's very easy to use the tool to perform the life cycle GG emissions evaluation. For this particular case studies, we are seeing about 15 years of payback time for the concrete uh, pavement be lower life cycle greenhouse gas emissions compared to the asphalt. And on the right-hand side, at the end of 50 years, the concrete is about 17% reduction compared to the HMA benchmarking. And that's just the GG. The cost is actually very comparable in the initial, which is just 2 years of difference. At the end of life cycle, it's about 16% of a cost savings if you're using concrete pavement for the particular case study in the hour. Another case study is partnership with Texas DOT. So Texas DOT were more interesting in the CRCP overlay of the GPCP because when they redo the GPCP overlay in the US 75, they are actually just doing the performance design. When the contractor finished the work, the DOT of Texas found that the surface roughness is pretty high. So you can see that the business zero, the BAU scenario, this initial CO2 is around 2 kiloton per land mile, but at the end it could be as high as 12 or 13. But we're actually suggesting if they can do some early age downgrading to different levels. For example, the purple will be downgraded to 70 to 95 inch per mile, or the green line to more aggressive to 65. You can see how much greenhouse gas emissions we could saving from the BU scenario about 12.5 to 5.7 to even 1.9, which are significantly contributing to the roughness PVI in the given case studies, indicating the MNR improvement for the pavement surface as well as the use phase emissions. The last case, this is the percentage we have been saving compared to the BU scenarios. So the last one will be the Indiana case study. Yes, we also partnership with Indiana for them to understanding what will be the optimized solutions for their new constructed concrete pavement. For example, when we're analyzing their new construct pavement for I-65, we can already define their BO CO2, which is 1.55 kiloton of CO2 per land mile, around $0.77 million per land mile. But what can they do better in the future? Or before they design the pavement, they build the pavement, can they already have a better solution to reduce the life cycle GG or life cycle cost or simultaneously? That's why we give them different options. For example, if they're only optimizing the design, when they're still using their business zero MNR schedule, they actually can improve 2% of CO2, 6% of the cost. But since they already have the given design, if they only want to optimize the future possibility of the MNR schedule, those are the savings of 5% of CO2, around about same of the cost. But in the future, if they're designing the new concrete pavement, if they just want to know what is the possibility from the optimization, not only design, not only MNR, but design and MNR simultaneously, how much they could be saving. So these are what they could save for this given study. Even though that is around 9%, 10% of the CO2 saving, 6% of the cost is still kind of millions of dollars or CO2, kiloton of CO2s for this just one mile, one lane miles. So this given case study just help us to understand, yes, Indiana has already do a good job for a better payment design because they are using more advanced payment design too. But how better they could do or what is the best they could do in the future. So those are the suggestions directly can be driven from the given framework or tool. All right, so here's the takeaways for the presentation today. So we're giving you one platform, full life cycle for the pavement, integrating the design, performance, MNR, LC, and LCC into the single major 6-step workflow, which is faster, smaller decisions, which you can play with, compare with different pavement alternatives, which are equivalent in the design and performance, but will have different life cycle, environmental and economic performance or impact in the future. And for the practice for DOTs or agencies, so we have partnership with different DOTs to help them to solve different problem or to propose different solutions based on the where are they, so which is so customizable and scalable for a better pavement design or the decision in the future, which are low carbon, cost-effective decisions, even before they build pavement. All right, so here is the website. I think Andrew already shared the link, but feel free to take a screenshot or just write down the notes and also use your phone to scan the QR code. And if you're having any questions, any comments of the tool, so as you know, we're academia, we want to improve the tool. We need your help. So any comments, questions, feel free to send me emails. Yes, I have a presented tool sometimes, several times in the past few months. A lot of DOT folks and colleagues from contractors industries already communicate with us. So we really appreciate those comments, which will be adopted those changes in next steps in the next version of the tool. Yeah, I think that's it. Thank you. Any questions from now?
All right. Thank you so much, Howard, for this great presentation talking about the updates that were done on the tool and the capabilities that were built within the tool to integrate the design, cost, and environmental impact calculations simultaneously and iteratively throughout the procedure of decision making for the DOTs and other pavement stakeholders, honestly. There are a few questions in the chat box, but I wanted to start with some of the general ones about would the slides be available for people to download after this webinar?
Yeah, thanks for the question. We'll be able to share the slides after the webinar. And yeah, I think all the participants will be able to access the slides. And also, as Andrew said, we'll have a YouTube video. Yeah, feel free to watch the video after the webinar.
Okay, so Andrew will record and or has already recorded and shared the video links on YouTube to everyone to be able to watch the details of the webinar and the tutorial that Hauran showed earlier as well. Some of the specific questions on one of your slides when you were showing the results section of the tool, you showed about a 6.5 inch minimum thickness for concrete and 8 inch maximum thickness. Is that something that the tool has designed for a 20-year design life, or is it something that was just as an assumption?
Yeah, it's for this given case study, I just performed a toy problem, so I used the tool directly to design the pavement. If I remember correctly, I may use actual uh, ME, but if you're having a specific pavement design or any 20-year, 30-year specific design, feel free to input your own numbers. And if you only have one numbers, feel free to make the min, max, and same values. If you already have the uncertainty of your thickness, you can just input the min and max directly in the tool.
Great. One of the attendees asked to put the website link one more time in the chat box. So, Andrew, I would appreciate if you could copy and paste the link one more time. Thank you. So, yes, you can feel free to open it. It's just to make sure that everyone is aware it's HTTP and there's no S after P. So, feel free to copy and paste and then create a login information. Um, there is a question about the maintenance and repair schedule in step 5. Is it something that is automatically determined by the tool, or does it require manual inputs?
Yeah, that's a perfect question. So we have tried to adopt every state's default MNR, but you can see that different state has a different MNR. They may change, they may not there. So we have some default values, but we highly encourage the user, if you have the data of your MNR, plan MNR in the future, feel free to put your MNR. So we give a lot of options. For example, for concrete pavement, we have a diamond grinding, full depth replacement, asphalt overlay, concrete overlay, and we have a lot of options which are the majorly used for the United States to repair pavement. If do not have any specific data, which means you have a lot of uncertainties. So that's the reason you give your MNR, but you have your min and max years to perform your MNR. That's actually gives you a lot more uncertainties, but still give you a sense what if still uncertain existing, what will be your distribution of the result? It kind of like give you both sides to play with.
Mhm. So there are preset values from DOT documents, lifecycle costing documents, but at the same time, there is this flexibility for the users to define the type, the thickness, and the age of the maintenance and repair schedules, from my understanding. Is that right?
Exactly. Yes.
Great. Similar question about the production emission. And where we think about the materials, the question is, does the tool apply generalized energy and fuel inputs across all concrete types? And does it account for emerging low CO2 production technologies such as
Yeah,
carbon capture or novel grinding methods, etc.?
Yeah, that's a perfect question. So for now, we're relatively using traditional way of the mixture design as well, traditional energy fuel consumptions for our paving materials. But we're aware of new or emerging materials, which actually in the next version of the tool, we will trying to give the flexibility, not designing the mixture, but also the innovative material and their related emission factors for the users to play with them. That will be the next step. Thanks
Mhm.
for the comments.
But the users, as long as they have the data about, for example, EPDs and any data sources, they would be able to manually adjust that. Is that correct?
Yeah, so you can see in our bottom right of this material emission factor, we have A1, A2, A3. If you already have those values already there, you can just replace those values. The tool will be
Mhm.
adopted. And if you want a detailed mixture design, then you go to the mixture design portion.
Great. Similar question about the data sources, particularly the life cycle inventory data. They're asking if it's a publicly available data or is it proprietary?
Yeah, especially for the raw material A1, A2, A3, the concrete data from the NRMCA uh, industry average, and the asphalt material emission data comes from NAPA EPDs, so they're all free downloaded. And for the modules of each pavement, the PVI, albedo, those are the data coming from the academic publications. So that's why we have those links for you to refer to the modules, how those emissions were calculated.
Mhm. Great. There's a follow-up questions on the maintenance and repair schedule, and it says, does the tool modify the maintenance and repair schedule based on material properties, for instance? Would the trigger point for maintenance intervention shift for different types of materials, or does it apply the same schedule regardless of the material's behavior?
If you're talking about material type, yeah, their schedules are different. For concrete pavement, asphalt pavement, their repair definitely different. But for material properties, we haven't embedded in the trigger time, but we expect the user to give their M&R schedule directly. But if you- actually we're considering for advanced user as well as the common suggestors, like if you're more willing to play with the tool for some advanced optimization level of this tool. For example, some level of triggers, you do this kind of M&R. We could do that in the next version. But for the public available tool right now, the default M&R was there. It won't be changed based on the material property, it won't be triggered. But we're actually having some publications already there, but haven't been involved in the tool for the public access.
Mm. You showed the results from Indiana on the
Yes,
optimization of the design and maintenance and repair.
exactly.
Is optimization something that has been built up in the tool, or how would you expect that to be performed?
Yeah, that's a good question. So we already have the model there, but we're not yet. Um, I think we haven't decided if we want to give the full optimization to the public if the many of the users do not need that features. But we may considering to have some advanced groups to have more. It's more about the technical or academic research level of the optimization. So what we'll think about to give that flexibility or affect features in the future of the tool development.
Wonderful. I don't have any other questions in the chat box. I would like to thank everyone for staying and for joining this webinar and for all the questions that have been posed. Please feel free to reach out to our email or Howron's email if you have further questions regarding the tools and how to use it, and if there was any feedback on the use of the tool, as Howron mentioned. Feel free to reach out, and we would be more than happy to hear your thoughts on that as well. Howron, once again, thank you for this presentation, and I will hand it over back to Andrew to close us off.
All right. Thank you very much to our presenters and to everyone who presented today. I thought it was a very lively discussion, and as always, we appreciate your input. That's what makes projects like this successful. So I would just close by saying, kind of like I mentioned before, so the recording for this will be publicly available on YouTube, and then everyone who registered will receive these slides as well as a PDF. So with that, thank you. Looking forward to seeing you next time, and have a great week.